Well, welcome to the Robotics Through Science Fiction podcast. And today's podcast is about exoskeletons. And I have Dr. Don Peterson, who's Dean of the College of Engineering and Engineering Technology at Northern Illinois. And he's also one of my favorite exoskeleton researchers. So Don, tell us about your research.
Well, my research got started with exoskeletons that were initially for rehabilitation, primarily targeting those hemiplegics, people who suffer from stroke, with the idea of building these technologies that could go home with patients so that they can go through rehabilitative exercises that they would normally do in a rehab environment, but do them at home. So that meant that these things had to be efficient, functional, and, the most important thing, low cost, so that they can either be purchased by the patient if they're not supported by the insurance, or insurance companies would support these things to be at home. The other key part of that low cost is disposable, because you're going to get situations where patients may not return them, and that can be problematic if they're quite pricey. They also need to be functional to a point where the patient can take care of it and understand it. And if something goes wrong, then a family member or a visiting nurse or somebody would be able to make adjustments and help the individual with this, essentially call it a mobile physical therapist, as opposed to going into the actual rehab environment. As my work with occupational biomechanics expanded and working with vibratory tools and materials handling, realized that the exoskeleton had a lot of use in terms of mitigation of biomechanical risks, such as vibration from tool use to back and upper extremity injuries from repetitive motions from material handling and so forth. So we had looked at the exoskeletons in the commercially available in the field and figured these things are tens of thousands of dollars to buy and use, and in most cases you have to even hire an engineer to take care of them. That's really not cost productive in typical occupational settings, and we really want this technology to expand, grow, and be used and adopted, and then they can get more and more expensive. The Model A car, when it first started out, wasn't a Cadillac. We essentially established a platform and got to that point. So we've been able to migrate our mission around developing low-cost, disposable exoskeletons for rehab into the occupational setting, and now we have a upper extremity strength augmentation device that we've had been researching and continue to research.
Okay, but you're getting such great uses for this technology. Therapy, occupational. It doesn't sound very science fiction-y at all. I mean, where's the science? Weren't you inspired by, these battle suits and big, giant manga and all of that? I mean, it doesn't sound it sounds too practical.
It sounds too practical, right? Yeah, but we all get our inspiration from those movies and those cool things that you see on TV or on the big screen, and you just want to do that. I want to put on a suit and fly around New York City, things like that. The aliens is always the biggest thing. Even myself, seeing Sigourney Weaver in that second episode of the Aliens sequence of movies come out in that big loader, it was called, that's really cool. I want one of those. So these, those types of programming and graphic arts, industrial arts, whatever you want to call it, is actually really inspiring, especially with Star Wars and other types of programs that have the robotics, and just looking at things that we do and how we can marry and carry on our own fantasies with what's going on in science fiction. It does play a big role. So like Pacific Rim, you look at huge. Are they exoskeletons? I guess they are in a way, right? The person's inside of it, controlling it.
Yeah, the giant pillars of Mecca.
Yeah, they're they're really controlling this whole system. Do you consider that an exoskeleton or a vehicle? The thing that Sigourney Weaver was wearing, the loader, is that an exoskeleton or is that a vehicle? Just different how the person is sitting in it and, quote unquote, driving it.
So you're thinking of exoskeletons. Your exoskeletons are more like Tom Cruise and The Edge of Tomorrow, or Elysium with Matt Damon, some of those other types of things. So it seems like we get in the movies either mostly the battle suits, right? It's mostly about our Iron Man just being cool and also a battle suit. Very little about the other kinds. Is there any particular exoskeleton that you like that you wish you could duplicate, or that the exoskeleton researchers such as yourself, you all go to a bar and say, oh, if we only had that particular one, we would, our jobs would be complete?
Yeah, the one worn by Tom Cruise is very attractive. But, there are all of those, that are extremely attractive. They're really cool. And you got to wonder, okay, at that time, if you can project yourself into that science fiction and become part of that quote unquote reality, how did they make it? And, what was the cost of the thing? And, how did they solve certain problems, from a materials and standpoint? And would a soldier that got hit, or the unit got hit and it just started to dysfunction, can the soldier just unstrap it and keep fighting? And, and could the military leave it there? Because, why? It didn't cost that much money and they can care less about it. You just would love to be able to project yourself into that type of situation. But all those suits are really, really cool. And I think they do, in some respects, project where we're going to be in the future, looking at the future in occupational settings, the future in military, maybe in the future of recreation. I could see sports where you have to don this suit and be able to play some cyber ball or something wearing an exoskeleton. But I think we're a ways away from there, and the science fiction certainly keeps us moving towards it because it's just cool.
So what, as a technologist, what's the hardest problem? You've already said something a little bit about the weight. When you were talking about how cool they were, I'm thinking, sure, as a former mechanical engineer, lots of moving parts and sand. Yeah, that'll work great.
Yeah, right.
You're talking low cost. You haven't really even touched on how the person interfaces with it. Like Hardiman was a complete disaster in terms of a person being able to control it. So what's the hardest technical problem? In many respects, it is the HMI, the human machine interface. In the case of exoskeletons that exist right now for use in industry, as a biomechanist, some of them make me cringe, because some of these exoskeletons will support the upper arm as somebody's working overhead, but what they're redirecting the biomechanical exposure, or therefore the risk that they're putting themselves under for a musculoskeletal injury. So something that would not have been under risk before becomes under risk, and under that type of loading may not have necessarily been a risk at that time. So now that you have the exoskeleton, you're introducing something that could be more injurious, and it could be more costly from a diagnosis, treatment, workman's comp, the list goes on and on. So being very conscientious. So I think it's the human-machine interface. And it's not just how the human interacts with the device to control it, manipulate it, to dance with it, in a nice choreographed type of way, but also what the machine is doing for the human, and is what it's doing, is it good, or is it having a detrimental effect? I mean, I could see a bunch of jello muscle individuals, because they rely on the exoskeleton to do all the lifting for them. What's that going to do in the long run? It could shorten we think about these things as enhancing, and it's only going to make us better or superhumans, but in many respects, it can also shorten your occupational life from doing that particular job. So yeah, like in Pacific Rim, you get the battle, anything with you're wearing a battle suit, your life is going to be shortened anyway. Right?
That's right.
So there would be that.
So to me, that's the toughest part. Yeah. I think we'll figure out the technologies in terms of carbon reinforced stuff, for the framing, new types of metal alloys. Motors are probably one of the biggest right now. Is very expensive motors that would be small. I should say the ones that small that are worthwhile are very, very expensive. Otherwise, you got to do some fun gearing and everything, and belting and all that, to pulleys and so forth, to get the same type of performance. But I think we'll figure those out eventually. But I think the human-machine interface is something that's going to be even longer standing. So we'll have a society. We're a society of tools, and yet we still have problems with, especially in the workplace, of having humans safely use tools. So exoskeletons will be there at some point. They'll be widely used and accepted, but we have problems with how they're used.
Probably abused.
Abused, right?
When you start talking about human-robot interaction, I wasn't thinking of the physical interaction, like you're showing with the musculature and how it physically fits and the weight and that. I was thinking of things like how that master suit type of relation, how you transmit your intent for the robot to assist with, which is usually handled in the movies either not at all or by, I don't know, telepathy, right? Or, things like we saw in Pacific Rim. You need two people and they do this. Or the Themis files, we need the same thing. So what can you say about that actual human trying to express its intent for the system to...
Yeah, and there are people, including ourselves, part of the rehabilitation, there are people looking at using electroencephalography EEG to have some level of control of the device, whether it even be from just a stop because this is hurting, it's moving too fast type of situation, to then move slower, move quicker, start to move, stop the move more precisely, and to work in concert with the individual's motion, and also linking it neurologically to muscle activity. So using what's called electromyography, and then when the exoskeleton senses that the individual is going through muscle activity, like say the biceps are starting to contract, that the exoskeleton will kick in and assist. Mm-hmm. Or there's maybe a threshold. When the muscle reaches a certain level of activation, then the device will kick in. And it'll stop knowing, okay, well, I'm not going to kick in until my user really needs the help type of thing. People are actively working on these types of systems. And there are low-cost solutions to this. So I think that's going to be something we will see, that the human will be choreographed nicely with the device. But then that's going to also present us with a whole set of new problems, depending on how they're used and new research topics going forward.
Well, that was spoken like a dean of engineering. He said, oh, no, we'll solve problems, but this will make more. Keep it job security for academics.
And us researchers, right?
Absolutely. So give it to me, sir. What do you think of Pacific Rim and the Jaegers?
Yeah, interesting. It's entertaining. And, you have to hand it to Pacific Rim, the others, with the exosuits, the video games. These are some pretty cool artists that come up with this stuff. And, it makes you envious. Like, man, I think I went in the wrong field because they've come up with some pretty cool things. And
some of which are not physically possible, but...
Yeah, and I think that
of some of that is like, no.
And I think that they're conscientious in terms of, they're not just going to come up with this cool design. They also think it's got to have some level of, it's got to be rational to some extent, that people are going to buy it when they're watching it and not be like, oh, that's really far-fetched, that'll never happen. And, it's almost like you want to get sucked into, with the science fiction of the technology as well, that, hey, yeah, that can happen and it's real and there, and I'm sucked in and drawn in and I'm part of it. So you got to give it to those folks. And I'm sure there's a lot of engineers that consult and, physicists and so forth, but these people are pretty cool. So I like it. It's entertaining, but I don't know if we'll ever see anybody battling Godzilla off the shores of Japan in a big exosuit.
What I liked was the UAV flying around, them to help spot for them thinking, wouldn't we just load up like a nuclear bomb on the UAV? But okay, never mind.
No, that's too easy.
Yeah, exactly.
You'd have a short podcast for a movie.
That's right.
It would be over.
So why do people love exoskeletons?
It is the attraction of the science fiction. These movies that do come out and they show that human life can be better than what it is currently. And we could do this through the technology that we have and the capabilities. And we see it from Iron Man and the other types of suits. We could be superheroes and everything's going to be great, if we wear this, and we're just going to be these superhumans. And I think there's a huge attraction to that. And I also think from the other standpoint that you get a lot of folks, especially the younger ones, the younger generations who are growing up with robotics and mechatronics, but still have this want to help people. And so I think they're drawn towards, again, making the human existence, the human body better than what it currently is. And I think there's this huge attraction to that. And I think that's why Iron Man has a huge following now. I think they did a great job with that movie and, building that fan base. And I think it's all about, when I see it with engineering students who want to do senior design projects around exoskeletons and so forth, they always talk about Iron Man and how cool it is. So I think there's that attraction. The movie's done a great job.
I love the idea of kids with spinal injuries being able to have their own Iron Man suit. I mean, that just the types of stuff that the medical exoskeletons are, it's just so exciting. And it's really important too for the occupational health and safety types of things. Well, we need to wrap up now. It's been really fun talking to you. Do you have any last advice to anybody who wants to go into research in exoskeletons or to learn more about them?
Yes, I do. I think there's a lot of information out there. There's a lot of the funding agencies out there. The military is interested in it. The National Institute of Health, NSF. There's a lot of folks. The Department of Energy are interested in it. We, the international community is gaining more and more recognition around it. As a matter of fact, I'm chairing currently the ASTM International Standards Development for Exoskeletons and Exosuits. And that's been remarkable. And I don't want to ever classify myself as a roboticist or an exoskeleton scientist in the way that these others can, because these people have been really working very hard their entire careers, or I've gotten in from a rehabilitation and have worked towards occupation. So I've kind of evolved that way. But being the chair of this international community on developing this exoskeleton and exosuit standard has been just phenomenal to me. To be able to interact with some of these folks have been very influential in what happens with exoskeleton technology out there, from the military to the occupation to the recreation to the medical. It's just absolutely a blessing. So you can go to ASTM's website and look up the activities that's going on around the standards development for exoskeletons and exosuits and see the wonderful things that these people are doing. And sharing the joy that I have in working with them. It's fun. It's awesome. So there's a lot out there, and I would encourage people to get involved with it because it's going to be an explosive field, and it's going to be one that I think is going to be very profitable for those who come up with some really good devices.
Oh, that's so cool. And I think you nailed it. I think you hit the nail on the head. The idea of the joy of the science fiction, and how it all comes together. Well, thank you very much, Don, for joining.
Thank you for having me. This is awesome. When are we doing it again?